Okay, so how do we write a good Prac report? So the underlined bits in this are from your task sheet, the back of your task sheet, where you've got a checklist. So just start with a general sentence about pepsin, then go into the structure of pepsin. You can just put in a picture of a chemical structure with a figure label and just a sentence explaining the chemistry of this. Don't make it too long. Then your function and background information. So what's it made from? How does it get formed? What does it do? Where's it located? Things that you think are relevant to this experiment. You might even want to mention tofu in there, or what type of thing tofu is. Then talk about your aim. So what are you setting out to explore in this experiment? So for your formative one, it was the effect of pH on chemical activity of pepsin. What is it in this experiment? So talk about it there. Also talk about, there would be a great place to talk about tofu. So this will be investigated by measuring the percentage mass change of blah. The activity is measured by this. Okay, then sometimes we write introductions after we write the discussion. You might want to incorporate, after you've written your discussion, a little bit of other science concepts that you use in your discussion, just really briefly, so you don't steal your thunder for your discussion. Then, this next bit is still part of your introduction, but it can be set out like this. So just put hypothesis. These should be underlined, they're not, it's okay. Hypothesis, if the independent variable, if we do this to the independent variable, what we're changing, then this will happen to the dependent variable, what we're measuring. Okay, so a variable is something like a condition, so don't talk about your dependent variable as being your percentage mass of change of tofu. What is that actually indicating? That's what it's indicating is your dependent variable. List your independent variable, list your dependent variable, then control variable. So other things that could explain, that could affect the activity of pepsin. So you did one last week in the formative Prac, pH. That could have affected the activity of pepsin. So we control it, we keep it the same. Other things like that, not things like the size of the beaker. Okay. Then list your materials and method. So that's really easy. Just list them in dot points. For your method, use present tense. I'm not going to talk about literacy stuff here, but just intro, method, present tense. Make sure it describes what you did. So it might be just the method of the task sheet, but you might have changed some stuff. If you have, that's great. Put what you did on here. Okay, now let's talk about results. So this will be in past tense. Now you might have made some observations which you refer to in your discussion as explaining what's going on. If you do that, put it in here in your results, and just put a little table. Then your task sheet says you need a table labelled above and a graph labelled below. With this table, you might have used a heap of data or just a little amount of data. We don't need to know all the raw data, okay? Otherwise you might, we don't need to know it. So put it in an appendix at the bottom. So if we go to see Appendix A, down here we've got Appendix A, we've got temperature, initial mass, final mass, percentage mass change. Also you'd probably put in here where you got your data from. Okay, so if you used all of B group, if you used just your class, if you use the whole class data, etc. So put in here where you got your data from so that we know that. Then where are we up to? Then you're labeling your graph. Label it below like this, graph showing relationship between this and this, what you've got on your graph. You don't need to put label, but you need to put labels, if you know what I mean. So write the words, but don't put the word label. Put units as well. Okay. Then describe the relationship. So this is not explaining it. This is not going into science. Results don't have science in them. They're describing straight off there what is the relationships that we observe. So if I saw 1 point there, 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 and my trend line went bang, I'd say there's a linear relationship. It indicates that there's the graph indicates that there's a linear relationship between the percentage mass change and the temperature change. So just describe your results. Don't explain them. Then I go into my discussion. Don't write a research project. Just can be short. Go into your discussion and start explaining the results you observe. That's what your interpretation bit is. You have done stuff on temperature in week 8 and week 9 in both enzyme learning and condition theory learning. Think about that. Think about how you can incorporate that into this practical. If your results didn't go the way that you thought they would, that's okay. Specify this. explain what you thought would have happened, and then as a segue into your next paragraph, say the fact that you didn't shows that there was some imprecision, and then you can talk about imprecision and reliability. So precision and reliability are really talking about how much of a data point spread out within the specific trial temperature. So say you had 20 degrees Celsius and you put that as proper units, and you had 25 and 35 and 45 and 55 and blah blah blah. Oh, they should all be over there. Anyway, so say you had those results. They're really spread out, aren't they? Okay, so that if you've got a spread out set of results like that, that indicates that there's a level of imprecision here. Okay, so that imprecision will reduce reliability and indicate random error. You talk about that for specific temperatures within each specific temperature. Okay. Not the overall scattering effect, just within specific temperatures. And so you might have really imprecise results for a trial at 20 degrees, but really precise results at 50 degrees. Explain that, talk about that. Just say that and say how you've shown that in this discussion. Do refer to your data, okay? Refer back to here. You can refer to specific data points. That's great. Never say something is precise. Never say something is reliable. Never say something, etc. Say it has a high level of reliability, high level of precision. Okay, then paragraph 3. Now this goes into errors analysis, strengths and weaknesses and improvements. That's the next bit. You might want to mash them all together somehow. However you want to do it, make sure you just meet it. You could just do a paragraph in each. So random and systematic errors. Remember, systematic errors happen all the time in the same way in every trial. Okay, that's a systematic error. When you're talking about your random and systematic error, it's really good to talk about the impact they have. So was it a massive impact on the results? Don't use the word massive, but did it actually have a significant impact? Or did it, sure, it happened and it was a random error and it's fine for you to say so, but it's good also to indicate this wouldn't have had much of an effect if it didn't. Then go into your strengths and your weaknesses. So it doesn't actually specify a number, but it's sources of error, so don't just have one of each. Okay, sources, plural. Strengths and weaknesses with the method. So think really deeply into this method. Okay, if you're talking about the strengths, think about consistent approaches that you use, things that you did to make it valid. So things that you did so that different pHs didn't actually come. You didn't actually. Your result that you found wasn't because you used different pHs. It was actually because you changed the temperature. Okay, so this would be like, I'm trying to measure the effective temperature on something, but I put it in a pressure of 0, and then the next time I measure it, it's in a pressure of 100. Well, actually, I might have measured the effective pressure on it. So what did you do to make sure you actually measured what you said you would? That's strengths and consistent approaches as well to reduce error. What was the method used? I don't want to say too much more than that, but is it enough to really provide good evidence for this trend? Okay, then 3 improvements. It says 3, so do 3. I'm sure you'll be able to find them. Think about your random and systematic errors, how you could stop them happening. Then in your conclusion. Okay, it says to write a statement in relation to your aim and hypothesis, so say whether your hypothesis was supported or refuted. I didn't put that in here, but it's on your task sheet. Refuted or inconclusive. Okay, so you might have said something that was supported to some extent, supported to a large extent. It might have been completely the opposite of what you expected, or it might have been a bit, you can't really work out what's going on. Fine, say that. Make sure you talk about at least one data point in here. Okay, so be sure to reference your data. Include a sentence that ties a relationship between temperature and pepsin enzyme activity. So a nice summary sentence about that, temperature and pepsin enzyme activity. In that you might want to, a summary sentence of your conclusion of your whole prac, you might also want to refer to pepsin's background or where pepsin's used in that. If your data has shown other stuff, that's good. Okay? Say that, yeah, your hypothesis was refuted, but this indicates that this is a potential trend. Okay? Then finally your references. Okay, with this, it says at least 2, do at least 2. Put them, make sure you're in text, so don't just plonk them at the bottom. So in-text, discussion, intro, they're really good places where you should have great opportunity to reference. Have fun!